problem 1-86. Make a complete graph of the function f of x equals the square root of x minus 2, label its x and y intercepts, and describe its domain and range. All right, let's get started here. I'm going to make an input-output table. And because I'm going to want to put points on my graph here. So I'm not going to just put 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on there. I'm going to choose values that'll be easier to work with. For instance, I know that the smallest value that's going to work inside the square root here would be 0. So I'm going to start out with 0. Then I know 1 is a perfect square, so I can take the square root of 1. I'll put it down. 2, it's going to give me an irrational number there, so I'm going to go ahead and skip it, and 3 and go to 4. So we can take the square root of 4. 5, no. 6, no. 7, no. 8, no. Maybe let's try 9 then after that. I know we're pretty much out of room, but we should have enough points to be able to get a good idea what the graph looks like. So when we plug in f of 0 there, we'll take it, we'll do plug in our 0, we have the square root of 0 minus 2 is going to give us negative 2. So we have the function f of 0 equals negative 2. When we plug in 1, f of 1 is going to equal the square root of 1 minus 2. In that case, square root of 1 is 1, and 1 minus 2 would give us negative 1. So f of 1 equals negative 1. We've got f of 4 is going to equal the square root of 4 minus 2. Square root of 4 is 2. 2 minus 2 is 0. Well, that'll definitely help us answer some of the questions above. And then let's just go ahead and do 9 here. We have function f of 9 is going to equal square root of 9 minus 2. The square root of 9 is 3, and 3 minus 2 is 1. So we have the function f of 9 equals 1. So let me put in for 4, I got 0. And for 9, I got 1. Let's go ahead and plot these on there. So for 0, we're at negative 2. So we're going to go down here. Here's a point. For 1, we're at negative 1. Now remember, we didn't do 2 or 3, so we're going to have to scoot over a little bit. We're going to go over 1, 2, 3, 4 to get our 4, 0 here. And then we're going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, we're at 9 there, and we're going to go up 1 to positive 1, and there's a point. So what your graph should end up looking like, I'm going to try to draw it as smoothly as I can. Should look something like that. Now our y-intercept here is the point 0, negative 2. Our x-intercept is the point 4, 0. Okay, the last thing it needs us to do is to describe the domain and range. So when we look at this here, our domain, okay, remember, domain's left to right. Our domain's talking about the x-axis here and what points we have. So we start here with one endpoint and we go on forever this way. So if we're doing it as inequalities, we would say that x is greater than or equal to 0. That's inequalities. If we're doing interval notation, we're starting at 0 here. That's our low end, and we're including it. So we're going to say bracket. We're going to put a 0 there, and then we're going to put a comma, and it's going to go on and on to infinity. So we're going to put infinity as our high end here, and we're going to close it with a parenthesis. The range. Remember, range now is going up and down. That's our basing it off our y-axis here. So our y-coordinates Our lowest point is at -2, and then it goes up forever. So we could say that y is greater than or equal to -2. And then for interval notation, our low end there, -2. Our high end would continue on up to infinity. So we'd have -2 with the bracket, and then infinity with the parenthesis there. That's it. That's problem 1-86. If you have questions, make sure you ask your teacher in class. Otherwise, thanks for watching. Hope this helped.